All right, so we're back. The reason I'm on this page is here's the problem we're doing. Okay, I've got two 8 ohm resistors are connected in parallel as our two 4 ohm resistors, and that situation looks like this. I've already drawn it. Well, I was knee deep into this video, and then like, oh, there it is. Okay, now you could answer this question if you wanted to take, 5 or 6 minutes, which I'm not going to do for your time, and go to this interactive PhET solutions simulations here. It is phetcolorado.edu. There's the you can just go to Google and type in PhET, and you'll get it. And here I started to do this one, but it was going to get too crazy to build. But you can build this, and then you can use the non-contact amp meter, and you can use the voltmeter to figure out what the voltage and amperage is going through those things. But you could build your little, because you could come in here and you could change your resistance value. So I could make this 8 ohms, and then build another one, bring out another one that's 8 ohms, and then just kind of build them all together, and build the actual circuit and show how it works. If you wanted to do it that way, you don't have to by any stretch. But you kind of start to pick up the patterns when you actually get to do some hands-on stuff. So this is what it looks like. Now, what is the current in each resistor? So let's take a quick look at what we have here. Now here we go. Now look, there's going to be a total current I coming out of here. And then it's going to come in here and it's going to split up. Part of it's going to go this way. Part of it's going to go that way. Then it's going to get back together again. And this is going to be a minus plus down here. A plus minus on this side because we're going conventional way of the current. And now it's all tied up again. Here's I again. And then coming back through here, we've got a current and back through. Now, you know that the current is going to be the same. We haven't done Kirchhoff's laws yet, but which is what we're going to do on Monday, will be the Monday video. You know that, but you can just probably intuit that the actual current flowing through each one of these two is going to be the same. So for right now, the only way that I know how to solve this problem is to turn this and this into two single resistors in series. So I'm going to call this the R1 set, and this is my R2 set. So R1 is equal to 1 over 8 plus 1 over 8 to the minus 1, which is equal to 1 over 2 over 8 to minus 1, which equals 4. Notice that is I bet you this thing better come out to be 2 or I'm going to be embarrassed. So R2, then, we're going to break that down. 1 over 4. Flip that over to the minus 1, 2.0 ohms. All right? So now with this happening, I can go, all right, I can just redraw this like this. But I know that this current is splitting in half here, so this would be 4 ohms, and this would be 2 ohms. Now, this I coming out of here, this is 12 volts. And then we've got all of I going through, the current going through there. Okay? So 12 volts is equal to 4I plus 2I. So 12 volts is equal to 6I because they're in series. And so the big I going through there, the total current in this system is equal to 2 amps. Total current in this system is equal to 2 amps. Now, what's the voltage drop between here? This would be 8 volts, and this would be 4 volts. You see why? 8, because this is going to be a voltage drop going through here, voltage drop going through here. 8 plus 4 is equal to 12, so it adds up. All right? Just just by luck because of the symmetry of the problem. Now, so let's just take a look at what happens at that 8 ohm juncture. Now we're going to expand this so you can see what happens here. So we've re-expanded it. And this is my 8 ohms. And this is my 8 ohms down here. All right, so here's what happens. And it's coming in, and so big I is coming in here, which we already know is 2 amps. All right, now I is going to flow, most of I is going to flow to the path of least resistance. Both of these have the same path, but I also know that from here, the voltage drop through here is 8 volts. If they're in parallel, both of those have a voltage drop of 8 volts. So this works out nice. So that's an 8 volt drop as it goes from plus to minus as I goes flowing through here. And this is an 8 volt drop. As it goes plus to minus, it goes flowing through there. This is 8 volts too. All right. We'll get more into the voltage drops when we get to Kirchhoff's laws in the next section. All right. But this is a good precursor, setting us up for it, setting you up for failure. And then the I's come back together. This IA here and this IB here come back together and go back into being 2 amps again. So what are they? They're going to, so 8 volts is equal to I times R. The resistance is 8, so I's got to be 1 going through there. And it's got to be 1 amp going through there. And the same thing is going to happen with the next resistor, and you'll see that they're going to have a 4 volt, 2 amps is coming in, so they'll be 1 and 1 also. So it's 1 and 1. All right, that's enough for just getting started on this. Out here. See you Monday. See you in class at 2 o'clock on Monday.